Assalamualaikum. I would like to present about the project 1B. The question of project 1B is apply the answer in question 1A using Matlab software and compare both of the result from the manual calculation and software based. Fuzzy inference system in Matlab is called Fuzzy Logic Designer. Fuzzy Logic Designer is design and simulate fuzzy system in interactively using the Fuzzy Logic Designer app or command line function, define input and output variable, set membership function, specific if and then rule, and evaluate your system with various input combination. So in manual calculation, fuzzy inference system, we can develop the system in using Fuzzy Logic Designer Matlab. My objective and problem statement for my fuzzy system is to solve problem the blender process. Factor variable can be impact the quality of the blender food and to consistently produce blender food that meet the desired quality standards. First step for apply the blending process using the Matlab. First step is open the Matlab and type Fuzzy Logic Designer on the command window like this and enter when enter the Fuzzy Logic Designer at the command window. The Matlab we open the window of the Fuzzy Logic Designer apps. At the Fuzzy Logic Designer, we can create the standard template fuzzy inference system. So commonly we use the Mandani method. So choose or click the Mandani type 1 to create the block diagram for fuzzy inference system. Step 3, when we click the Mandani type 1, so the Matlab will open the fuzzy inference system plot. At the fuzzy inference system plot, we can modify the requirement of property editor, which is to identify the input and output variable in the system, determine the range and parameter, and define the membership function for input and output. For my system, have two input variable, speed and blending time, and one output variable which is the quality of food. So input and output variable at the name at the property editor, and range based on your scala at the manual calculation using the Mandani rule, and at the table consists the name, type, parameter. So for example, blade speed, so range is 10 until 0 until 100, 100. So it is my range the graph. So I put the name. She is membership function, linguistic variable, low, medium, high. So type trapezoidal, triangular, and trapezoidal. And last, determine the parameter. Parameter, how to create or determine the parameter. We must to see type. So when choose the trapezium have the uh, 4 point. So which is 0, 0, 30, and for 30 and 60. So the graph like, oh, you can don't see. I will explain at the step 5. Step 4, we stay at the fuzzy inference plot. So before that we explain. First select the type that can be triangular or trapezium shape, and each member function represent or logistic variable like low, medium, or high. So blending time. So name is the represent the membership function or logistic variable, short, variance, long. So this is the type of the shape and this parameter. So step 5, at the membership function plot viewer, you can see the fuzzification process. That is the graph. So input 1, input 2, and output 1. Step 6 is create the fuzzy rule base. So at the fuzzy how to create rule. So click the rule editor, and first click clear all rules and add the rule, the plus green, click the green plus green color, and modify the rule at the property editor. So first connection is NOR if. So this two input. So we can use the select the what the rules we can. So for example, two rule of the system. If blade system is low, the blending time is average. Then quality of the food is rough. So second rule, if the blade speed is high or blending time is long, then quality of the food is smooth. Last step is step 7. So we done the create the rule. So click the rule inference to simulate the system. When you click the rule inference, so open the rule viewer to see the rule evaluation, aggregation of the rule output, defuzzification of the output, like the picture. So this is rule evaluation, and this is aggregation of the rule output, and the last graph is the defuzzification of the output. So to the- to know the to find the center of the gravity is 4, 4, 40.5 quality percent of the quality of the food. So at the input value is the like the test variable. So you can put any any value like this, or change to output by using a slider to model different scenario and evaluate how your fuzzy system respond. So you see the sliding at the graph, so you can move the disk and input value can change. So we can see the difference of the area bounded. So based on the calculation, manual calculation and fuzzy logic designer using Matlab. So this is discussion comparison of manual calculation and Matlab software result. So we get the manual calculation is 38.63%, while the Matlab result is 40.5%. So this is not different, like no far difference. So this is discussion comparison. Lastly, it is general comparison of manual calculation of Matlab software result. They expect method, efficiency, accuracy, complexity and consistency. So the comparison, general comparison. That's all for me. Thank you.